Right, good morning everyone. So this morning we're going to do a quick revision on vector and scalar quantities. So in Form 3 we would have looked at the 5 fundamental quantities, and we established that they were length, mass, time, temperature, and electric current. Of course, they were the basic quantities, and we had also what we call derived quantities. We also established the fact that in physics, or in science in general, there is a need to measure different quantities. So these quantities can be divided into two types: vector quantities and scalar quantities. Right? So I'll first start with scalar quantities. Scalar quantities are quantities that are described only by their size or magnitude only. So they just have a size. For example, length. Let's say you are buying a length of cloth, for example. You could say, I want 3 meters of cloth, or 3 meters of some particular material, right? That's a length. We only describe how much, in this case, 3, right? So if we're looking at, let's say, the mass of an object, for example, the mass of an object can be 20 kg, 10 kg, 100 kg, right? We only describe how much in terms of the quantity, 100 in this case of 100 kg, and so on. So some quantities are described only by the amount, their size, or their magnitude. There are also some quantities, right, that are called vector quantities, and this is a different class of quantities. So if you look on the board, you would see that they are described by two things. We can describe both their size or magnitude, and I forgot to mention that sometimes we use the word magnitude, in this case in physics, as the jargon for the amount or the size, right? So vector quantities are described by their size or magnitude, and also their direction. So some quantities also have a specific direction. Their directions must be taken into consideration, and those are what we call vector quantities. Let's look at some of the examples: displacement, velocity, acceleration, and momentum. Displacement is simply length or distance, right? A length is a distance, as you know, right, in a particular direction. So if I say we traveled a distance of 10 meters, that's our distance, or the length that we traveled, how far we traveled. But if I say distance, if I traveled 10 meters northwards, I am no longer talking about the distance I traveled, but now I am talking about displacement. I have now stated both the distance, 10, the amount, the magnitude, right, 10 meters, as well as I have stated the direction, north, right? So some quantities have both a size and a direction. All right, size or magnitude and direction, and the directions allow us to be able to add and subtract them in different situations, and so on. So that's the fundamental difference between scalar quantities and vector quantities. Scalar quantities are measured by their size or magnitude only, whereas vector quantities have both size or magnitude and a direction. Now, as far as measuring direction goes, directions can be measured in terms of our cardinal points: north, south, east, west. They can be measured in terms of angles, or what we call bearings, as well, right? So it's very, very important that we understand that directions can be measured in different ways. However, we must remember that quantities are either vector or scalar. Now, we haven't really come across vector quantities yet at this level. We will be getting into that very soon. And the ones displayed here, displacement, velocity, acceleration, and momentum, will be the key ones that we will be looking at in the coming days. So I'll see you soon.